Hi, I'm Paco Nathan with O'Reilly Media, and we're here at the O'Reilly Artificial Intelligence Conference in New York City. And today it's a pleasure to be joined by Bill Roberts, your Managing Director of Deloitte Consulting. So first question, what's some of the process that you use to think about artificial intelligence in a business context?
So it's interesting, in a business context, it's more than just the algorithms. Frequently, it's a difficult process to get all the data.
Right.
We've got to navigate our clients' data structures,
Right.
which can be siloed, they can be integrated, but whatever, that's kind of the first step, gathering the data, linking it together in a meaningful way, and making what we refer to as a model-ready data set.
Okay.
So that's kind of step one. Step two is then applying algorithms to that data set. That's its own process around measuring the performance of the algorithms, making sure that they solve the business problem,
Right.
coming up with some sort of assessment of their business impact, at least from a model perspective. And step three of that process is about deploying those model results in a way that the client can action, deploying them within the client's workflow. That depends. There's a wide spectrum of approaches that we do that. It could be just to populate a field in a database that is then leveraged by a customer management solution, or it might be an entire kind of platform that's needed to leverage those results.
I wanted to ask about problem solving also, in terms of what is an AI approach toward commercial analytics and problem solving?
Okay, so the way we tend to do the science portion of that, to problem solve around the science portion, is whatever that business problem is, we've found that we see the same types of analytic problems over and over.
I can imagine.
Yeah, we see a lot of classification problems involving, for example, deep learning or some other classifier. We see a lot of segmentation problems. We see a lot of problems involving sparse and incomplete data. We see a lot of problems involving simulation. But it turns out there's only a dozen or so different types of problems, of what we call problem classes, that we apply for a multitude of different business problems. And then the challenge is around finding the right algorithm. Of course, there are thousands of algorithms. The best algorithm in any given scenario depends on what does the data look like. Is it sparse? Is it noisy? Is it incomplete? And so that selection of models depends on the kind of data characteristics.
What's the importance then of using the proper algorithm for a particular business challenge?
Well, the right algorithm will give you a lot more performance.
Okay.
So that's the kind of short answer. Longer answer is there's a lot of interest in different approaches now. Deep learning, as I mentioned, well, that's a great approach if you have, for example, a lot of data.
Right.
If you have a lot of data, then that's a fantastic approach generally.
And labeled.
Yeah, and labelled, exactly. If your data is small and if your data is sparse, you could still have a meaningful business problem that involves solving a small, sparse data problem, and it's probably not going to be a deep learning algorithm that you're going to kind of land on as your approach.
Excellent. So I can imagine that you get to see a lot of these types of implementations over and over, and you can really develop a deep bench of sort of that matching between the approach and the problem.
Well, exactly, yeah. So as a consulting company, we have a lot of clients, and we see a lot of different problems, and we can start to make inferences about seeing things we see over and over. And that can really help us. That can save a lot of time in scoping out the right team, scoping out the kind of initial approach that team might apply. Of course, if they learn more during the engagement about the particulars of the client or the client's data, maybe they'll try another approach. But we can certainly get them going very quick because we have this knowledge that we've seen from a lot of clients.
Fantastic. I wanted to ask also about the process, classify, segment, and learn for analytics algorithms.
Yeah, so that's an approach we've kind of formulated when you have a problem where you want to change for example, customer's behavior. So one way to think about this, let's say you have a churn problem. Step one is that customer likely to churn? That's a classification problem. It's a yes or no problem. Binary classification problem. Step 2 is to find the segment that customer kind of resides in. What are the characteristics of that customer and other customers that look similar? And let's try and group them. That's the segmentation part of classify, segment, and learn. Okay. And the last part is the learning part. How do you actually find a treatment to apply to that customer in order to change their behaviour? That's a learning problem because we don't actually know the performance of all the treatments. So we've got to apply treatment, see if it works. If it does work, we have some knowledge. If it doesn't work, that's some knowledge too. We do that learning phase with what we call explore and exploit algorithms. So sometimes those algorithms exploit, meaning they apply the best treatment, and sometimes they're exploring, meaning they're trying another treatment, just so that they know, the algorithm knows which treatment is best, and it can kind of revisit its thinking as circumstances might change.
Excellent. That strikes me as perhaps taking reinforcement learning strategy and applying it to business.
Yeah, it is. Explore and exploit is really just another word for reinforcement learning. Yes, exactly. Yeah.
Fantastic. Thank you very much, Bill. It's been great talking to you today.
Oh, great. Thank you.
Thank you.